Integrating e to the x. So when we were differentiating e to the x, what do we remember? Okay, good.
But e to the x differentiates to e to the x.
Yeah, e to the x differentiates to e to the x, so which should therefore make integrating e to the x pretty easy, right? Well, it's really easy if you're given the question e to the x dx, right? Because yes, e to the x differentiates to e to the x, so therefore going backwards, it integrates to e to the x. Plus our friend c, right? Because we don't know what's vanished. So that one particular situation is really easy. But we need to learn what I call compensating. So we are going to learn to compensate. And we are compensating for whatever happened during differentiation. So if in differentiation, let's say we had y equals 5e to the 5x, right? dy by dx would equal
25e.
Right, so 5e to the 5x times 5, right? Whatever the power differentiates to. So kind of like a little chain rule. So we end up with 25e to the 5x. So what we have to compensate for is what this power did for us. When we were doing an integral of 5x squared dx, what did we do? We added to the power because we knew that's where it came from, and we divided by the new power. This bit here is compensating. All right? That's the compensating we're trying to get to terms to doing. Okay? And that's because when we had 5x cubed, x cubed, and we differentiated, what happened? We differentiated, we get, right, we get this bit. So if we were going this way, all right, from here to here, trying to get back where we came from, then we need to add 1 to the power and divide that 45 because we multiplied by it over here. So we're compensating for what we did when we were differentiating. But we're not differentiating, we're integrating. So what we have to do is, in everything we do, compensate. When we were learning this bit, it was really easy though, it just made sense. Add 1 to the power, divide by the new power. Well, now that we're into all the other functions, it's not as easy to compensate. So what we have to think of is, what would have happened if we had the integral of 25e5 to the x? We've just differentiated it over here, so we know we're trying to get back to 5e to the 5x. All right? But when we integrate that, it says, okay, there's 25 of these, and we integrate x, we get e to the 5x. All right? But we need to compensate. We're compensating for that number there, that 5. And we're saying, okay, our compensation is we need to divide by that 5. So that number there tells us we need to divide this by 5 to get back to where we started. So again, this is us compensating for what happened to that particular variable. So therefore we'd get 5e to the 5x plus c. All right? Yes?
Mhm.
Okay. So if we had this one, what's going to happen? Yes? Yep, you may. All right, why? Right, so it's as though this was in brackets, all right? So the integral of this is this, all right? And we had two of them, so we have two of the answer. And our compensation is for what this differentiates to. And this differentiates to 1. So we're dividing by 1, which we don't write down, plus c. All right, so that's a little bit of a tricky one. Okay, your turn.